welcome. In this video, I'm going to do a brief walkthrough of the current state of Ikigai. In the future, I think I would best describe Ikigai as a agent orchestration platform, but today it's probably best described as a terminal coding agent, much like Cloud Code. And I think that the first thing I'll say before I dive in is that it is in a very early tech demo state. Probably only about a fourth of the eventual features are available, and the user interface is one of those things that has been ignored up to this point. It only exists so that I can demonstrate the more foundational features. And in fact, that's kind of my goal with this video, is to demonstrate those foundational features and how they're different from other coding agents. With that, I'm going to launch Ikigai. A lot of the output in Ikigai is very debuggy in nature because I am still working on it primarily. What you're seeing when I just launched it, you can actually see that I did this, but I happen to have cleared its context and exited from the previous session. But what you see here is that on an empty context, the very first thing it loads is the system prompt. It's a pretty primitive system prompt. It's just a little bit of information that it needs to be able to use some of its features right now. And that, of course, matures over time. The most foundational difference between Ikigai and a lot of other agents, and this gap is closing a little bit, but it was one of the first things that I had built in, is that Ikigai has a permanent memory. So if I say, if I ask it a question, it's going to go out and do a quick little web search for us, and it's going to come back and say, here's the weather conditions in London, and we now have that conversation in history. If I exit Ikigai and I return to Ikigai, you can see that all of that context is there. We picked up right where we left off. There really was no change. And that context is available from that previous conversation for all future conversations. So, for example, I can say, and it shouldn't. Yeah, it did not go out and do a web search. It just used that context from the previous conversation to be able to answer that question. Okay, probably the next thing I want to show about Ikigai is the current state of its tools. Ikigai has a really unique system for tools. The tools are actually external binaries that are sitting in a tools folder. And the reason that I do that is because it allows people wanting to do plugins the ability just to create a tool that has native performance. Essentially what these tools do is, in fact, maybe I'll demonstrate one here in a second, but essentially what these tools do is they have a JSON RPC that is just used over standard in and standard out. And so pretty much any bash script can become an internal tool from Ikigai's perspective. It's anything that's executable and anything that responds to the schema in the correct way. Ikigai has all of the required pretty much foundational tools that a coding agent needs to work. We got bash, we got the file editing, we got the search stuff. We have a list tool, which I'll kind of explain here maybe in a second. We have web fetch and we have web search. Now, initially I had implemented web search with both Brave and Google APIs, but it turns out that just this week, Google discontinued, as it famously does pretty much everything, its web search API. And that greatly simplifies things for me. We will only have web search and it will be through the Brave API in the future. These tools all work like you would expect. So if I say, if I ask it to read and summarize a file, it will go out, and you'll see here, and this is kind of a difference with Ikigai, you're actually seeing the tool calls being displayed. Again, Ikigai is in a much more debug state, and me as the developer, I much prefer to see what's going on here. But you can actually see that it made a tool request to use the file read tool on that particular path. The tool request returned a truncated bunch of information, but it created a summary for us from that tool read. And likewise, all of the tools work the same. You would already, in fact, up here, we had seen the web search tool used. One of the things that is maybe a little unique is the list tool that I have built in, and it's an experiment. I'm not sure if I'm keeping it in exactly the same way. So right now, each of the agents has this concept. So this just happened to be what was in the list, but it has a list of just one item. And I could say something like add a cat, dog, and is it salamander? And so what you can see here is it's using the tool to add additional things. Oops, I think it might figure that out anyway. It did, and so then it showed me back, here's the contents of my list, and I can say fetch the first item. And what the list is just a built-in tool for it to help keep. It's like a to-do list. It's just a built-in tool that it can use, that it can stuff what things on and pop things off real easy. And that becomes very useful in helping plan and execute tasks. Okay, so kind of enough there. The next big thing to show off with Ikigai is agents. So in Claude Code, you do have subagents, but they're kind of hidden behind some tools, and realistically, the top-level agent is the only thing that interacts with them. But what I can do here is I can actually fork a new subagent. And this is a little subtle right now, and the user experience will have to be adjusted to show this. But one of the things you'll notice is that we have this message right here that we forked into this child agent. And if you watch this here, it's going to change. And what it's actually right here is telling us, hey, your parent is this UUID, and you're currently this ID, and you're currently this subagent. And I can navigate between them. So I just popped up into the parent agent, and you can see that it's telling me that I'm this ID. Now the parent agent, and the forked agents, of course, have separate histories. So I just asked an additional question on the parent agent about 42, but if I drop back down to the child agent, it doesn't know anything about that context. And I can ask it, just some other random question, and it's going to go out and do a little web search. And these two agents have completely different histories. One just forked from the other. The one is a child of the other. If I ask again, I can see the relationship between these. This is a process tree, and it really has no limit to how much it can sprawl. The way Ikigai is intended to work in the future is that there really is going to be a one-to-one kind of agent sitting at the top that you work with, and you're going to have these sub-agents that are probably attached to different functionalities or different projects or whatever it might be. And those, again, will even run sub-agents when they're off doing tasks. I can, so here, let me take this. You can see that I am currently in the subagent here. You see the XQ in the square brackets. That is the subagent. And if I want to send a message to the parent, I can. it's kind of a pointless message, but the child agent just sent a message off to the parent. And now if I wanted to so let's list the mail first. So check mail. And you can see there's old messages that are sitting on the queue. But at the top of the queue here, I have that message that was just sent from that particular child. And I can say read mail 1, and I got the message back off of it. So the agents can send messages back and forth, and that will be the primary way that they communicate. There is some missing functionality here. The agents themselves cannot create agents yet. That's something that's very, very soon on the roadmap. Let me take a look here. What else do we got? So I showed the mail. I showed, one thing I haven't shown is that it is you can use many different models. So we were currently using Gemini. It reported to us before. Actually, let's just, what model are you? And it will probably tell me I'm a large language model trained by Google. And if I say model, GPT-5 mini, what model are you? Sometimes Claude especially, or Anthropic's models especially, tend to take offense when they see something like this in history. So even OpenAI is doing it. Sorry for my confusion. I was inconsistent. So it's noticing that it called itself trained by Google before, and it's like, hey, I wasn't trained by Google. So it calls it out. And the third provider that we currently have is and I guess I wasn't showing it, but we also, unlike in Claude, you can explicitly control the thinking level. So what we have is, let me set that again. So let's go to model. We'll do GPT-5, just GPT-5. And if I do a slash there, I have a choice of saying none, medium, or none, low, medium, or high. And all of the different providers provide different ways of setting their thinking budgets. And what I've chosen to do for now, and it might not be the permanent way, is that if I say none, I set the thinking budget to 0. And if I say model GPT-5 medium, I set the thinking budget to, well, at low it's 1/3, at medium it's 2/3, and at high it's 3/3, so 100%. So you basically get to set it in thirds or to none. And while I'll probably make it so that you can pass through the underlying native concept of thinking budget, I think that I'll also keep this abstracted form too. So for example, like Google's even changed in its models. In Flash 2.5, in the 2.5 models, you could set a token amount for thinking budget. In the 3.0 versions, you only get to set low or high, I think is how it works. And so these things change over time. And so I'll probably, almost certainly make it so you can pass through the underlying native implementation, like whatever it is. While at the same time, keeping these 1, 0, and 1, 2, and 3/3 mappings so that you can have a uniform way regardless of which model you're using. It turns out that thinking budgets, at least the way I use them, and I think that this is going to be generally common, is there isn't a significant difference between 5K tokens and 7K tokens. What you're really looking for is these big changes as you shift through. None, a little bit of thinking, a lot of thinking, is really generally what you need. Okay, so that was the stuff for, I haven't shown you mark and rewind yet. So the way mark and rewind works, this is about, so clearly if I say clear, that clears the context. Actually, let's go down here. I also wanted to show, so I'm back in the sub-agent here. The way that you can kill them is you can kill another agent by saying kill and then it's UUID. Or if you're just in the agent and you say kill, here we just killed that subagent and we pop back up into the parent, and you can see there's only the one running agent again. Now, what I wanted to show right here was my perspective on how rewind works. So let's have a little bit of conversation here. How would you improve the... We'll see what it does. We'll think for a couple of seconds here. In Cloud Code, for example, the way rewind works is you do a rewind and you pick your point in conversation. But I like the much more, while maybe I'll do something like that in the future, I like the much more explicit version of it where you set a mark. And these marks can actually be named. I probably should have shown that, but I could have done, like, for example, mark space foo, and then later on mark space bar, and then at some point in the future I could decide to rewind to foo or rewind to bar. Without a parameter, it rewinds all the way back to the last clear. I probably asked it to do a little too much work there, but this is a good example. You can also see right now that, of course, it's walking through a bunch of tool use, and that that's an interesting little effect. What's going on, I don't know exactly what's going on, but there must be a line feed that's happening it's essentially a bug. There's a line feed that's happening in the render display for every one of the spinner's animations, and so that's walking up the screen. It might not be obvious, and that is a bug that I have to fix. I've never seen it before. It might not be obvious because the performance is pretty good, but the entire screen is getting re-rendered with every one of these spinner changes. I haven't optimized the rendering to only render the changed portions yet. But the performance is generally so good in the terminal display that you really don't see it. Okay, so it's I asked it too big of a question there. I didn't want to wait that long, but we'll let it finish here. It's rewriting the world, and eventually it finishes. And all I really wanted to do was to rewind and show you that it just rewinds to the mark. I probably should have had something before the mark before I did that. That is effectively Ikigai. I am going to demonstrate one additional little piece, which is what I meant about the external tools. So if we look, so it's in the libexec. Yeah, it's libexec Ikigai. So these are all the tools that exist currently, and so you'll notice that those matched what we were seeing. All that Ikigai is really doing is it's enumerating its libexec directory and saying, okay, if and then as it enumerates it, it has a little conversation with each one of the tools, and if the tool pass, then it says, okay, I will include you in the list of available tools. So if I go libexec Ikigai and run the list tool and ask it for its schema, what it's telling me right here is, and I don't have this prepared, so I won't be able to do it, but what I would be able to do is to do something like, maybe I can do this on the quick. So the parameter, the operation parameter is required, and I just want to list, I think that I'm going to put the item in there anyway. I don't know if it's required, but I know, so item. The tool, the Ikigai is doing this for you behind the screen, so it's not like something you would normally do. But if I echo that to libexec, or if I feed that to libexec Ikigai list tool. Oh, that didn't work. But that is essentially how it works behind the scenes is anybody can provide a tool. It just goes in that folder. What it has to do is it has to, I messed up the, I really messed up the, Ikigai agent ID is not set. And so it doesn't know where to find it. Ikigai agent would be set if we were running Ikigai. But the way that the tools work is that they are external binaries, and you simply pass in some JSON to them, and they pass some JSON back out. And it's in exactly the same format that tools work inside of. You literally just take that JSON and send it to the agent. So there's no overhead in it. And we get the added benefit that anybody can add a tool, and then they can design a skill that uses a tool, and there's no overhead. That is the design decision that is going on with that. Okay, that was a quick rundown on what Ikigai is, how it works today. It continues to evolve. So thanks.